Hello learners, Mr. G here, and today we are going to make another video related to application of Newton's law. In this case, there's going to be two objects. It's a system of two objects connected by a string, but the two objects are moving in different directions. So let's see how to solve this question, and I hope you do understand. Okay, so let's read the question so you have time to answer the question by yourself, and then just compare the solution with mine. Okay, the question said a 4 kilogram block on a horizontal rough surface is connected to an 8 kilogram block by a light inextensible string that passes over a frictionless pulley as shown below. The coefficient of kinetic friction between the block of 4 kilogram and the surface is 0.6. There is the drawing. You can see that you have a 4 kilogram block, you have an 8 kilogram block. This system, the question does not say it, but the system is moving in that direction. Okay, it is moving there. All right. Question 1.1. Draw a free body diagram of all the forces acting on the 4 kilogram block. To 1.2, there is a problem with the numbering here. This is 1.2, 1.3, 1.4. The number is not really a big problem. 1.2, write down Newton's second law of motion in words. 1.3, calculate the acceleration of the system. And 1.4, calculate the tension on the string. Okay, so we have here step 1, we did it already. It is reading. Step 2 is write the data. We have here the drawing, and there is already some data given. However, we know that the kinetic coefficient of friction for this block is equal to 0.6. That is for this block, because this is the only block that is experiencing frictional force with the surface. Okay, you can't, if you want, you can draw the forces here. However, it's not important. We're going to do it later on. We know the object is moving in that direction. So for this 8 kilogram block, the object is moving down. Moving down. Therefore, down will be taken as positive. Remember, in one of the previous videos, we said we take the direction in which the object is moving as positive. So for the 4 kilogram block, to the right is positive. For the 8 kilogram block, down is positive. So here's all the information more or less of the question. Let's start with the solution. Question 1.1 said, draw a free body diagram of all the forces acting on the 4 kilogram block. The 4 kilogram block is the one that is on the surface. We can here in the same drawing very roughly draw the forces so you can see it. Here is the tension. This is the force from the rope, that is called tension. There's frictional force on the backward direction, opposite in the direction of motion. There is gravitational force or weight acting on the block, and there is the surface acting on the block with a normal force. So those are the 4 forces acting on that block. For this 8 kilogram block, the forces that are acting are weight or gravitational force, and then is tension that is on the rope. Okay, remember this tension and this tension is the same because it's the same rope. Okay, so we're going to draw the free body diagram for all the forces acting on the 4 kilogram block. So let's go to draw. Let's write here solution to start answering the questions. Okay, so solution. The question 1.1 is to draw the free body diagram for the object of 4 kilogram. So the free body diagram is, there is the dot, what forces are acting there. To the right there is tension. To the left in the opposite direction is going to be frictional force. Pointing upward is going to be normal force. Pointing downward is going to be the weight. Alright, so those are the forces acting on the block. If this was for marks, you will get 1, 2, 3, and 4 marks for drawing the free body diagram. Okay, let's go to question 1.2. Now, question 1.2 said, write down Newton's second law of motion in words. So I'm going to write the definition, and I'll be back in just a second. All right, so here we are with the law. The law said when a net force acts on an object, the object will accelerate in the direction of the net force. The acceleration is directly proportional to the net force and inversely proportional to the mass of the object. This question will have or will count 2 marks. 1 mark for saying the acceleration is directly proportional to the net force and acceleration is inversely proportional to the mass of the object. There is 2 marks for this question. Okay, so let's go to question 1.3. Sorry, question 1.3. Now, for question 1.3, they say calculate the acceleration of the system. Remember, we're going to work separated as we did in the previous video. So here, we're going to say for the 4 kg block, and here we're going to say for the 8 kg block. And we are going to draw, the first step is drawing the free body diagram using the axis. So let me draw the axis and I'll be back in a second. Alright, here we have the axis for the 4 kilogram blocks as well as for the 8. Let's start with the 4 kilogram block. Let's go there and let's see what forces. We have already a free body diagram. So the forces acting on that object in the x-axis, we have the tension force pointing to the right. We have the frictional force pointing to the left. Those are the forces we have on the x-axis. And on the y-axis, we have the weight pointing downward, and we have the normal force pointing upward. That is for the 4 kilogram block. For the 8 kilogram blocks, we have only 2 forces acting vertical. Remember, we did the drawing on the sketch, so we have tension upward and weight downward. So we have here the weight downward and tension up. Now, what is important here? Remember, the direction we take right as positive here, and here will be down as positive. Okay, so let's go now to the next step, which is applied Newton's law. Now, to calculate the acceleration, what Newton's law we are going to apply? So we're going to apply Newton's second law. Okay, and that states that the net force is equal to the product of mass multiplied by acceleration. All right, we're working in the x-axis. For this object, we're working in x-axis. So what force we have? The tension, positive because to the right is positive, minus frictional force is equal to mass multiplied by acceleration. We're working here. All right, on the x-axis. Now, what is the small problem here? We don't have the frictional force. It's not given to us. So the first thing we're going to do is to calculate the frictional force. So let's write here the formula for frictional force. Frictional force is equal to the product of the coefficient of kinetic friction multiplied by normal. And once more, we don't have the normal. So let's try to get how to calculate the normal force. Okay, now how to calculate the normal force? We are going to go to the y-axis. We're going to the y-axis because the normal force is in the y-axis. So we're going to work here. This object is at equilibrium in the y-axis. So you can apply Newton's first law, which is F net is equal to 0. What forces I have in there? There is normal minus W, or weight is equal to 0. Normal is equal to W. So normal is equal to mass multiplied by acceleration due to gravity. Normal is equal to, this one is 4 kilograms multiplied by 9,8, and the answer for normal is 39,2. 39,2. You can check the calculation, make sure it is properly calculated. So this normal here is going to be substituted in there. Okay, so let's now calculate the frictional force. We can substitute here to save space. The kinetic coefficient of friction is given and it is 0,6. is there, 0.6. So we have here 0.6 multiplied by normal, which is 39.2. All right, 0.6 multiplied by 39.2. So the answer is 23.52. So the frictional force is equal to 23.52 Newton. Now this frictional force is going to go there. All right, so we are calculating everything separated. Okay, so now we have tension. We don't know the tension minus 23.52 is equal to mass, which is 4 multiplied by A. We cannot go on because we have two unknown. This is going to be called equation 1. Okay, so we stop there and we go to the other block. The other block we're going to use Newton's second law. We have net is equal to ma. Now in y-axis we only have one axis with A forces, which is the y-axis. What we have down is positive. Note, down is positive. So it's W weight minus tension is equal to ma. All right, we don't have the weight, but we know it is mass multiplied by acceleration due to gravity minus tension is equal to ma. If we substitute here, we have 8 multiplied by 9.8 minus tension is equal to 8a. Okay, if you calculate this number here, you will get 78.4. You have 78.4 minus tension is equal to 8a. We have two unknown. We stop here, and there we have now equation number 2. So what are we going to do now? We are going to add equations 1 and 2. Okay, so I'm going to write here adding 1 plus 2. Now, when you do the adding, there is different methods. You can't, if you want, you can substitute. You can substitute for t, or you can use different mathematical methods. I like to add, so I'm going to add everything that is on the left-hand side of equation 1 with everything that is on the left-hand side of equation 2. So it will be t minus 23.52 plus 78.4 minus t, and then it's coming the equal. Now I'm going to add everything that is on the right hand side of equation 1 with everything that is on the right hand side of equation 2. So it will be 48 plus 8a. Alright, and now here, this is simple mathematical calculations. We have noticed that the tensions cancel each other. T minus t is 0, and the rest is simple calculation. Okay, so let's do the calculation. Now it's negative 23.52 plus a positive 78.4. This one gives us 54.88. So it is, let's keep the same color. It is 54.88. All right, equal to 4a plus 8a is 12a. So a is equal to 54.88 divided by 12, and that gives me the acceleration is going to be 4.57. 4.57 meters per second square. Okay? That is the final answer. I hope it is clear. It's not that difficult. You only have to follow all the steps. Okay? Now, for the last question, which is calculating the tension of the string. Now you must note in question 1.3, you're supposed to give the direction of the acceleration. Now it is to the right for block of 4 kilograms, and it's downward for the block of 8 kilograms. Okay, so that will be the direction. But this question actually is going to ask for the magnitude, okay? Because they're moving in different directions. So question 1.4, yes, 1.4 is to calculate the tension. So to calculate the tension, you have to use either equation 1, which is T minus 23,52 is equal to 4A, or you can use equation 2, which was 78,4 minus T equal to 8A. So let's do both just for you to see that it's the same. T minus 23,52 is equal to 4 multiplied by the acceleration, which is 4,57, and then the answer for T will be equal to 41,8 Newton. And if you use the second equation, you have 78,4 minus T is equal to 8, and multiplies the acceleration, which is 4,57. So if you move T to the other side, you have 78,4 minus 8 that multiplies 4,57 is going to be equal to tension, okay? And that, if you do the calculation, you will get also 41,8. Okay, so that is the answer. This is the whole question. I hope it really helped. It's not that difficult. Go through the steps, go through the work. Next video we'll do something else on Newton's law still. I think this work is difficult and is useful for grade 11s and grade 12 learners. Remember, the grade 12 are going to have Newton's law in all the examinations as from now up to the end of the year. Okay, will always be a question of Newton's law. Thank you very much and good luck to all.